Shweta Shah and I am your instructor for the subject Microprocessor and Microcontroller. In this subject we have started Unit 4, that is VR Assembly Language Programming. In this session we are going to see today the topic, that is the data transfer instruction for 8MB32. So let us start with the topic. In data transfer instruction we are having so many number of instructions, like we can have move, LDI, STI, LD, ST, or push or pop. So many instructions are available. We will see that instructions one by one. First one is the move instruction, in which we can transfer the data between two registers, from source register to destination register. In LD instruction we can load the data from particular memory location, or we can load the immediate data to that particular register. We can also use the instructions like ST or STL to store or store immediately, or we can use the LPM instruction, that is the loading the program from memory, that is your flash memory. Okay, and in this the hardware control for the loading register R0 with register Z, that is our combined register R30 R31 is used. Okay, this is basically a loading the program memory, or you can say access the flash memory. Then we can use the in or out instruction, that is for accessing input and output port, or we can use the push or pop instruction for accessing the stack. Push is used for storing the data into stack, and pop is used for getting the data from stack. Okay, so these are the basic instruction that we can use for the data transfer task. We will see this instruction one by one in detail. First one is the move instruction. In this instruction copies the data from one register to another register, and this data can be copied between any general purpose register, that are R0 to R31. So you can use any of this 32 register. And the syntax for this instruction is like MOV, that is your opcode, or you can say operation code. Then you have the RD, that is your destination register, where you want to store the data, and RS, that is your source register, or you can say where is your data that you want to store. Okay, so for example, if we consider the instruction like MOV R10, R20, in this instruction the content of register R20 is used, and that is going to be stored inside the destination register, that is R10. Okay, so this kind of instruction we can use for storing the data into particular register from another register. So before instruction, if the content of a register 10 is something garbage value or blank, we can consider like this, and the content of register R20 is like 25. Here this dollar sign indicates the hexadecimal number. Okay, and after this execution of this instruction, this 25 that you have stored inside the register 20 is going to be stored inside the register R10 as well. Okay, so this kind of instruction you can use for transferring the data between two registers, any of these two general purpose register. Next instruction we can use is the LDI instruction. This is used for loading the immediate data. Here these 8-bit immediate data can be copied into any of general purpose register. Okay, and this word immediate indicates the value that must be provided right there with the instruction. Okay, so you have to provide the particular value that you want to store inside some register in the instruction. Okay, the example for or you can say syntax is like this: LDI RD, K. Here LDI is the operation code, RD is the destination register, and K is the 8-bit value that you want to store inside this destination register. But here in the RD register we have limitation that we can use only R16 to R31 for loading the immediate data. Okay, so we can't use register R0 to R15. So after for example, if we can consider it like this: LDI R18, 4A. $4A indicates this number is the in terms of hexadecimal. So this will be like this: if before instruction the content of register 18 is like blank or some garbage value is there, then with this instruction we have provided the data $4A. After execution of this instruction LDI R18, $4A, the content of register 18 is going to be stored as $4A. Okay, so this 4A is the immediate data that is going to be stored inside the register R18. Okay. Here we cannot use register R0 to R15 for the immediate data transfer, that we have to consider. Okay. Next one is the LDS instruction. In this, this is the instruction for loading the direct data from the data space. That is your memory. Okay. To load the 1 byte from the address in the data memory to the general purpose register, we can use this instruction LDS. Syntax for this instruction is like LDS RD, K. Here RD is the destination register, and after the execution of this instruction, this RD register is stored with the content of the location K. Here RD can be R0 to R31, anything can be there, but here this K is the destination, okay, that we have to consider. For example, we have instruction like LDS R5, $202. Here 202 is the location. From that location, whatever you have stored at that location is going to be stored inside the register R5 at the end of the execution of this instruction. And this location in the data memory can be any part in the data space. It can be in IO register, or it can be data SRAM, or it can be a general purpose register. Okay, so from data memory, particular location you will provide in terms of K, and that data from that location is going to be stored inside the destination register. For example, if we have the instruction like this LDS R5, 202, here this 202 location stores the data 6C. Okay, so after the execution of this instruction, the content of register R05 will be 6C, because we have used the immediate data transfer with LDS instruction. Okay, so this kind of instructions are also possible. Next we can see is the STS instruction. This is similar to LDS, that is used for loading data. This STS is used for storing the data. Okay, this is the store direct to the data space. Syntax for this instruction is like STS K, RR. The content of register RR is copied into the address location given by the K. Okay, here RD can be R0 to R31. For example, STC $202, R4. Here the content of register R4 is going to be stored at memory location 202. That is the data memory space. 202 location of data memory space. So this is like this. If our instruction is before execution of this instruction, if the content of register R4 is like A9, then after the execution of this instruction, this content A9 is going to be stored at memory location given by 202. So this will be like this. And if your content of register R4 is like A9, then after the execution, this portion is before the execution. At that time, at location 202, you have stored something like 3D. But after the execution of this instruction, that content is overwritten by A9. Whatever you have stored inside the register R4, it will be overwritten by that data. Okay, so this is the data transfer instruction STS. And here also we can't store immediate data into SRAM, but we can store that immediate data into the general purpose register, and after storing into general purpose register, we can use this instruction to store at that particular memory location of SRAM. Okay, so this kind of thing is also possible. Then next we will compare the data memory address versus the IO address. Each location in IO memory has address as a two address. IO address, and second one is the data memory address. That is, you can access by the IO address also, and you can access by its data memory address also. The data memory address of the IO location is unique, and the IO memory address is the address relative to the beginning of the IO, called the IO address. So it can be changed. And in 8MB32 the data memory address can be varied from 000 location to 085F location, but the IO addresses can be fixed and that are from 00 to 3F location. Okay, so this is the fixed thing for the IO address and the memory address. Next we will see the in instruction. It is used for load the IO location data to the general purpose register, and syntax for this instruction is like in rd comma a. Here a is the data that you are getting from that input port, and that is you are going to store inside the destination register. Here this value of a can be 0 to 64, that is 0 to 3F, 00 to 3F in terms of hexadecimal, but if we consider in terms of decimal, then it can be 0 to 63. And here RD is a general purpose register that can be 0 to 31, any of that register. For example, if we consider like in R04, 0 cross 3F. Here this 0 cross 3F is the port number. Contained from that port is going to be stored inside the register 4. So if we consider this kind of scenario, before the execution of instruction, the R4 is having some garbage value or 0. Okay, after the execution of this instruction, the port number 3F, whatever the content of this port number 3F, that is 3E, is going to be stored inside the register R04. So our content of register R04 will be F3 after the execution. Okay, so this is the in instruction. Similarly, we can use the out instruction. In the out instruction, we have syntax is like out a comma r. Here this instruction is used to store general purpose register into the IO register. Okay, so here we have the value of a similar to in instruction, that can be 0 to 63 in terms of decimal or 0 to 3F in terms of hexadecimal. And the value of RR, that is general purpose register, that can be R0 to R31. For example, we can consider it like out $3C, R04. Here $3C is the port address that is that you are going to using for giving the data into the output, and the content of register R4 is going to be stored at that particular port. So if before execution of instruction, the content of register 4 is like AA, and this port values are like this. $3C is containing FE, then 3D is containing 3D, 3 is containing 03, and so on. But after execution of this instruction, the content of register R4, that is AA, is going to be stored at location 3C. Okay, so after execution, the content of 3C, what is before that execution, that is FE, is going to be replaced by the content AA. Okay, so by this way we can use the out instruction. Then we can use the next instruction can be like LD instruction, and this is the load direct instruction. This is used to load one byte from the address pointed by the general purpose pair, that is the X register, Y register or Z register. R26 and 27 is your X register, 28 and 29 is your Y register, and 30 and 31 is your Z register. Okay, here we have the syntax as a LD, RD, N. Okay, here the content N indicates the X, Y or Z register, and the content from the location that is given by this X, Y and Z register are going to be stored inside the destination register. For example, LD R5, Y, and this Y register is used for pointing the memory location, and the R5 is R29 is the higher byte and R28 is the lower byte. And if the content of R29 is like 02 and R28 is like 35, then the actual address or actual location given by this Y register is 0235. And after execution of this instruction, the location content of the location 0235 is going to be stored at the register 05. Okay, so before, if it is having 0 value, then after execution it will have the value of that particular location, that is 0D. So 0D is going to be stored at the register R05. Okay, similarly we can use the instruction ST to store the content. Okay, the syntax for this instruction is like STM, RR. Here the content of register RR is going to be stored at location given by this N, and this N can be X, Y or Z registers content. Okay, that is the memory location. And for example, we can consider it like ST Y, R05. Here if we consider the content of Y is like 0235, so that our location will be 0235. Before execution of the instruction, if the content of this register R5 is like 0T, then after execution of this instruction, that content is going to be stored at the memory location given by the Y register as well. That Y register is 0235. So this content 03 is also going to be stored at location 0235. Okay, so this is the instruction which we can use for the storing the data. We can consider more examples, like if we have the instructions like LD R20, $80. In this instruction, the content of this is the immediate data, and that is going to be stored inside the register R20. So after execution of this instruction, 18 is going to be stored inside the register 20. Here $sign indicates the hexadecimal number, that you have to remember. Okay. Then we have the instruction MOV R19, R20. Here the content of R20 register is going to be stored inside the register R19. So what is the content of register R20? That is 18. So that is also going to be stored inside the register 19 also. Okay. Then if we can use the instruction LDI R20, $2A. So this will used as an immediate data. So 2A data is going to be stored inside the register 20. So after execution of this instruction, 2A is going to be stored inside the register R20. We can also use the instruction like MOV R19, R20. So for the second time, the content of 20 register is going to be stored inside the 90. So the content of 19 register will be like 2A. And after that, we can use the instruction like STA $237, R90. So here the content of register 19 is going to be stored at memory location given by this data memory location given by this 237. Okay, so after execution of this instruction, the location 237 will contain the value of register R19, that is the 2A. Okay, so by this way you can use any data transfer instruction to store the data. We can also consider it like this. If we have the instruction LDI R28, $38, this will store this 38 immediate data into register R18. Also we can use the instruction like LDI R29, $02. This will store 02 inside the register 29. And we know that this 29 and 28 register combiningly known as the register Y. 29 is the higher byte, 28 is the lower byte. So after that we can use the instruction like ST Y, R20. So this will store this content of register 20 into the memory location given by the Y. What is the memory location given by Y? That is the R28 and 29, that is 0238. So 0238 is the our location where we will store the content of register 20. So here this is the R29 and 28, that is our location, and the content of 20 register, that is the FB. After execution of this ST instruction, the content of memory location 0238 is going to be stored as FB. Okay. Similarly, instead of ST, you can also use the instruction LD. So at that time, the content of that particular memory location that you have stored by immediate values is going to be stored inside the some register. Okay. Also you can load, also you can store. Similarly, this is for loading. Okay. Here we have used the register X, that is R26 and 27, combiningly known as the X register. 27 is the higher byte, 26 is the lower byte. So that is the content, that content is 0238, and the content of register 20 is like VB after execution, because at location 0238 you have stored the data VB. After execution, this VB is going to be stored at register 20. Okay, so by this way you can use this LDI instruction to store the immediate addresses. You are storing the immediate data, but that immediate data is your address, and by using that address with LD instruction in terms of X, Y and Z register, you can store the data. Okay, so this kind of instruction also you can use. So here we are ending our today's session. If you have any query, then you can contact me.